Today I'm doing a special request for Steve, who emailed me. He said I haven't done a compact 40, and he's right, I haven't done a compact 40. This comes in 4 guises. It comes as the Binatone or Binatone, however we want to pronounce it, Beambreaker. It comes as this, the compact 40, but distributed originally from Western Electronics, and presumably when they went out of business, stocks were bought by Wagner, so they're marketed as the Wagner Compact 40. Also appears as the Falcon FCB 1281, and it also appears as the Merit, which model number eludes me at the moment. This is one from my own collection. So it does work, it has been serviced, but I'm going to nevertheless go through it again for this video. And it says on the back, Win Industries Company Limited, Tokyo. So I'll take it apart. We do have a circuit diagram. And the circuit diagram, which we have, is for the Binatone Beambreaker, which shows it as a 5-pin mic. And it's 4 on these, but nevertheless it's basically the same circuit. And I can't really fault these radios, you know, they seem to work and they seem to be very reliable. And I'll take the lids off and show you. There we go with the lids off. It's compact, it certainly is, conventional components. It's got 2 boards in it, as you can see. Got the top board with the channel selector and some other electronics on it. The PA's at that end. Audio IC, ILO power at the back. I've got the air conditioning on in here again, so I hope it's not too noisy. You're probably aware that I usually wear a lab jacket in the workshop because of static sensitive devices. So just when I could do with sitting here in a t-shirt and shorts, I don't really want to zap any static devices, and you will appreciate that lots of semiconductor devices are like that, so we do all these wrist straps and all that kind of rigmarole. Right, so on to the radio. Well, I'll just make some notes and then I'll be straight back with you. Right, I'm going to tread very carefully with this because the circuit diagram doesn't appear to match up with the component numbers on the sample in front of me. So we'll just I've just worked out a chart of adjustment, but we'll tread carefully. So I'm going to go into transmit. I can't demonstrate the VCO to you because I don't know the procedure. There's 2 wax sealed coils, T9 and T10, which are accessible through these holes. Just move it up there a bit so you can see there's 2 holes in the top printed circuit board there to wax filled coils below. And so the first one I'm going to start with is L11 because it is transmitting, and so we need to be peaking that, followed by L6, followed by L7, I'm going to backtrack on that because it can be interactive. And then we've got a filter arrangement. So I need to use my plastic green tool for this. And we have full 4 watts on that radio. Now I think we'll just be prudent at this stage to unsolder the loudspeaker. These have a tiny little meter on them, and so somehow when I press transmit, I'll have to read that and set the meter preset accordingly. Okay, setting the RF meter is R89, which is that one there. I'm just going to zoom in because you've got 5 presets there. Low power. This is the one for the meter, so I'll just tilt that up so I can see it, and then that's set for the 4 watts. The next thing we'll do is switch over to low power. It's the switch at the back. That should be doing 0.4 of a watt, and then we're just adjusting resist to 88 for 0.4 of a watt. It's a little bit dirty, so just a quick spray with the service oil switch cleaner. And then we have 0.4 of a watt on the meter, switching it back to the full 4 watt power, and we've got the full 4 watts. Now what I'll do is we'll do the deviation next, and there's 3 things I do in generating the tone for deviation. Now in a factory setting, and if you look at the service manual, what you're supposed to do is you'll be injecting from a audio generator straight into the mic socket. Now, unless we've got about 10 radios the same, we don't do that, but use a small oscillator which we hold in front of the microphone in front of that. And that's because we want to do it with the microphone that it's supplied with. So, I'll switch that oscillator on. It's 1 kHz tone. And then adjusting the deviation control, which is resistor 90, which is the far one at the back. And then that's now set for peaking at 2.5 kHz. Now the other 2 tests which we need to do, I do a whistle test to make sure that a peak voice is going to not over deviate it, and it has. Now we'll go back to the oscillator. I'll drop that to fraction. Check it again. This time we're set right, it's not going above 2.5 kHz. And the third test, which you're supposed to do, I don't always do, is the wah-low test. And it all sounds stupid, doesn't it? Wah-low. And again, that's another voice peak to make sure it's not going over the correct deviation. So I'll recap on that. The factory way to do it would be put it in through the microphone socket instead of a microphone. And it'll say in a manual what level it is. It's normally 4 millivolts at 1 kHz. We use an external oscillator which we put the microphone near. Check that it's within reality with a quick whistle test, and then the wah-low test. So it's absolutely bonkers, I know. When I was at Nottingham Radio, Mr. Smith didn't like us to use an oscillator at all, and he wanted you to set it up on a whistle test only. But that wasn't how I was taught, so there we go. Different people have different ideas, and when you work for them, you obviously you do as you're told. Right, so that covers the deviation. That's done that. We'll put it on frequency. The trimmer for that is down there because there's the crystal, 10.24 crystal, and the trimmer is that just there. So we'll just check that it's on frequency. It's 27.79125. It's reading 27.79130. So I don't need to adjust that, but it is the trimmer capacitor just there. And that concludes the transmit setup on the Compact 40.